Welcome to Conservation of Energy with Brogan Ballou, Campbell Reed, and William Brock. Today we're going to test the concept of the conservation of energy. As you can see, we have a track here, 3 tracks actually. Each track has a different path, one going down, one going immediately down, and one having a slight taper off. Each track will be starting from the same exact height of 10 inches, or 0.234 meters. Each ball will be dropped from the very top of this track at the exact same time. Each ball will then travel down the track, and it will shoot from the end of the track. The ball will then be in projectile motion. It will fly through the air, and it will then hit the paper on the ground. The paper on the ground, as you can see, is being measured from the exact point of launch. This will tell us the distance that the ball has been launched. Let's take a look at this video. As we can see, the balls start from rest and do not travel in the same path. That leads us to this question: which ball will travel the furthest after the launch? So, which one did you choose? Well, surprisingly, all 3 balls should land roughly in the same location. This is due to the conservation of energy. Each ball starts from rest, each ball starts from the same height, and finishes at the same height, and the mass does not change from point A to point B. So, theoretically, as calculated above, each ball should exit the track with the same velocity. Also, each ball is leaving the track at a horizontal projection angle. As learned in previous courses, projectile motion implies that each ball will travel with roughly the same horizontal distance due to no acceleration in the x direction. Let's test it out. As you can see, each ball hit at a different time. Here, we will drop the ball and we will mark exactly where each ball hits. Ball number 1 is dropped. Ball number 2, marked as well. Lastly, we drop ball number 3. Ball number 3 is also marked. As you can see, as the camera comes in, there is an X mark on each spot, roughly a little over 21 inches, all the way across the board. As we take a closer look, we can see that each X mark is roughly 21 inches from the point of launch. This means that the conservation of energy held, and it is true. Each ball launched at a horizontal projection angle with roughly the same velocity. In conclusion, though it may seem impossible, an object such as a ball can have a completely different path of travel, yet finish with roughly the exact same velocity and launch distance due to the conservation of energy. Thank you for joining us today with Mr. Brogan Ballou, Mr. Campbell Reed, and Mr. William Brock. We hope to see you again. Thank you.